have mentioned around $980 billion in revenue alone. To get marks, your strategy should be completely different. If you want to understand the subject, your strategy should be completely different. Obviously, these two will get coincided at some specific point. I would suggest to take device physics. That was the moment I transformed from a regular ECE student to an engineered physicist behavior.
I am Chaitanya, third
Hi,
year
hi.
ECE from our Shastra University, and this is
Okay,
Nithin,
which
you know,
is he core or VLSI?
core, core.
Core. Oh, okay, okay. Good.
Hi, Anna.
Same
I am
class?
Nithin. Both of
There.
us
Yeah,
same
yeah,
class.
both same class.
Okay. So
Yeah, yeah.
ECE core, Anna. And
Okay.
so we welcome you to the second episode of this podcast series.
Thank you.
And today we have here Mr. Srivarshan, who was an ECE core student in Shastra University. Anna, could you just introduce yourself?
Yeah, sure. First of all, like I thank you guys. I really appreciate. Thank you for inviting me to this podcast because I really appreciate the effort that you are taking to bridge the gap between seniors and juniors. Like that will help a lot of people who aspire to do something impactful in their college journey as well as in the next phase of their life. Like I truly appreciate this effort. And like introduction, I'm Srivarshan. I'm basically a physicist with engineer's mind. I joined Shastra University to study ECE just because, honestly, I was obsessed with Tony Stark. You know, Marvel character,
Yeah,
Tony Stark,
Yes, yes.
yeah,
right? Yeah. So I obsessed with
Iron Man.
Tony Stark and his tech world. So that spark led me to work on several projects in my university and to invent few ideas. So that even we filed 3 patents with that. And also, I had the opportunity to lead my team in an international industry collaboration with industry like Global Foundries. So, like, they are one of the world's top semiconductor manufacturers. Currently, they rank third globally by revenue. And today, I'm associated with Global Foundries, supporting their US fab in New York, while also running my own YouTube channel named an engineered physicist. Here, we have a team where we break down physics and explain physics very basically. That's it. That's about me. Very short.
and that's a wonderful introduction.
That was really great, Anna.
Yeah.
Thank you.
So, Anna, let's jump on to the questions now. So, when you joined Shastra, what
Yeah.
were the first 2 years of Shastra? I mean, your BTech journey. What were the first 2 years of it look like? Uh, like, what was your approach towards college life?
Okay. So in my first year, the first semester was actually online. Like everybody, so I'll like leave this first semester alone. I'll just cut that first semester because nothing was happening in the first semester. We just online classes were going in my laptop screen, and parallelly Big Boss was going in my mobile phone. So that was like a web series. I watched those things. The in second semester as well, it was like normal. I experienced a basic normal school days behavior only because that is the first time we get into a college, right? In person, I'm saying. So like after the second semester, my journey actually began at my third semester. That's where so during my school days, when I got interest in physics, like uh, in my school days, there is one faculty named DBM sir who made me fall in love with physics. Like Bosco sir reignited that spark. Physics was always my favorite subject because of Tony Stark. But then I started feeling the physics, not just learning it for marks. So the third semester is really like a starting point. That's when I realized, so this is where I belong. That was the moment I transformed from a regular EC student to an engineered physicist behavior. So that was up to my third semester. In fourth semester, I took like one elective that most people said not to take that elective. So that is device physics actually. So everyone will fear for
Okay.
device physics. I just took like because intentionally I took because they are fearing just to see what is there like, and I just studied the device physics elective. It was really very interesting to me. After that, like I scored some S grade in that. And after that, I approached Muthubalan sir. He was asked me to come to his lab, Professor Muthubalan. You might know, right? You took
Yeah,
device physics. Yeah. So have you studied in his class?
yeah, in his class only I studied.
Okay. Okay. Okay.
Yeah.
So he will be teaching
Yeah.
like extraordinarily. Even I attended in online only. The lectures were online. Even then, I enjoyed the lectures. So that was the like teaching that he taught. So after this device physics course completion, one day suddenly Muthubalan sir, like I was going to the DML lab frequently just to learn the TCAD and physics behind. He used to tell me to study HEMT device, high electron mobility transfer study, right? I think you might know, you might be
Yeah.
able to
Yes. Now.
the device. Yeah, Nithin is working on SIGI HPT kind of device. HEMT is like another
Yes.
parallel device that is a growing device. So I was used to study the physics behind the HEMT device working and in parallelly the TCAD software, right? So one day suddenly Muthubalan sir came to me like, Srivarshan, we are going to get a project from GF and you are going to lead the team. I was like, so they are Global Foundries is like one of the world's, it is a dream company for everyone. Like we have Google, Meta for IT students, right?
Yeah,
These are their dream companies.
Yeah. Yeah.
Global Foundries is one such dream company that mostly peoples from IITs and NITs can only able to get into that company. So that was
Yeah.
their like standard. And I was like, when he was telling, when my professor was telling you have to do this project, it was like representing Sastra University from BTech point of view to an industrial giant, semiconductor giant like Global Foundries, right? So that was
Yes.
really my moment. And from there, I had so much responsibilities. And I started to build a team. I first asked my friend to join in my team. His name is Yogesh. I trained him, and we have other team members as well in my team. And the presentations were going on like we have to do some deliverables to the Global Foundries, GAN team to the US. From US, a team will be coming, and from Bangalore, a team will be coming for hearing our presentation. Like they will assign some task to us. We have to do that in TCAD. Basically, I cannot tell so much of things because NDA has been signed. So to give an overview, what we will do is in the project, they will they have an experimental data. They will have some unexplained phenomena that they cannot open the device and see what is happening inside, right? So in TCAD, we can see all those things. In TCAD, we can literally open up the device and see what are all the electron density, where the potential is changing, where the electrons are sitting, like all those things we can tell. And from that, we can able to identify the physics behind the operation and any unexplained phenomena. So like that, we got one particular problem statement from Global Foundries, and we solved the problem statement. I mean, our team, and the same we did as for our college main project as well. So the same
Okay.
project we did for our college main project, and in later in each semester, uh, we were working on three patents. So like three new ideas we had, and we filed three patents actually till then. That was my college experience.
That sounded
that's
really
super. Yeah, yeah.
great now. Actually, yeah. So now I would like to ask you one more question. That like, what were your initial days in device modeling lab look like? You were a new student in that lab, and how I mean, how did you get adopted in that lab environment? And the while hearing the complex terms like TCAD and all, uh, like what were your thoughts and the challenges faced?
Like you're asking what are the challenge that I faced, or like my experience completely you're asking, like
Yeah,
Only
how
during
you
the initial days of the
overcome
lab.
that challenge?
initial days initial days, you see, I joined in fifth semester
Okay.
I joined
Okay.
the device modeling lab. Initial days I was literally blind. I don't know where to start, what to do, nothing. I was also blind, like any initial phase of the
Yes.
any project that we do. But I had one thing clear, like even to highlight one particular thing, when I saw the manual of TCAD, I was just seeing, okay, I thought like it may be some 2 or 3 pages, like what are all the uh, pages we have in the, I mean, TCAD, what are the windows we have, what are all the models that we run. I thought there may be some 2 or 3 maximum, it will be 10 pages of any manual. But I'm scrolling. When I see the number of pages, it was 1500. I was like, there were sea of parameters that were in the TCAD, and like number of projects that were built in the TCAD itself. I was literally about to quit to leave the lab. I was literally
Oh,
about to leave the lab, but I had one thing in my mind. I just asked myself why I started. So that question I think is really important for any of you whenever you get this kind of confusion in your early days. So that sparked me,
yeah.
and I just went through the basic learning phase. And when the project came, it will be then the so, see, when you know what you have to do, when the why is clear, then your how is easy, right? So that is the
Yes.
basic idea. Your initial days always will be like that only. You will be having a lot of confusions, but you have to go with that flow. You have to, because you can say like I'm just going blindly. I cannot understand what is I'm doing, or like what to do next. If you have that kind of questions in your mind, you just come out of your mind, you just see in some other's perspective. Other people are not even doing the thing that you are doing. They are not even started doing that. You are just started, right? So you just have that boost and pick up from there, and you can go. So like that you have to be in the initial days.
Okay. Okay. Now,
That's
so
really
do you want to ask
Anna,
any
one
question?
thing I want to ask you.
Yeah.
What's your passion, Anna?
Sorry.
What's your passion?
Passion. My passion
Yeah.
is physics, electronics physics,
Did you
device
find
physics.
it in college life or before joining the college?
Before joining in college itself, I had passion in physics because of the character, right? Tony Stark.
Yeah.
Yeah, that's nice.
Anna, one more question is
Yeah.
that you are from you have an ECE background, right?
Yeah.
So, and physics is, and as you say, physics is vast. So,
Yeah.
what made you to particularly choose this device modeling and semiconductor physics domain rather than signal processing and RTL design or similar domains?
Device physics. To be particular,
Yes.
it's device physics. I took even before the device physics phase, I had no clue about. I just like general physics, as you said. We have other things as well: signal processing, communication domain, and we have some FPGA kind of those things we have. But to
Yeah.
be specific in semiconductor, why like I had that particular interest means after taking the device physics part, because Bosco sir always will insist in the class like take device physics as your elective, take device physics as your elective. I just followed it and I took the device physics. Suddenly I started, while studying the device physics, suddenly I started realizing, oh, we are actually uh, like studying the miracles of the universe. You are actually studying that the things you cannot see. See, in FPGA, in coding and all, you can see and you can touch and work with the devices. Like in communication as well, you can
Yes.
see the physical things actually, right?
Yes.
But
Yeah.
device physics, it's not like that. It is like you have to imagine in your mind that if you give electric field in this direction, electron will move this way. You cannot see that actually. So that particular interest, right, that particular imagination, you literally you need to imagine. You cannot like other subjects, you cannot study it like seeing or experiencing it. You have to imagine in yourself, in your mind, and you have to understand from the imagination, and the result will come out like that. So that is the basic spark that like involved in me towards the device physics, and that suddenly transformed into semiconductor domain because I joined DML lab in ASK.
Okay. Yeah, exactly. Now,
Feel the electrons, right? Bosco sir always mentioned
Yeah.
this.
Oh,
We should feel the electrons and all this stuff. So that really made interesting.
yeah, actually, as you said, Bosco sir has guided the many students like this. And so let's jump on to some of the projects that you have worked on over the years.
Yeah.
Um, so could you please give an overview of the projects and the papers
That you
published
have.
by you over the years?
Papers, I think we are the paper I have not published patents filed as of now. Papers we are just started to upload in the IEEE. We are yet to get some review actually. So
Okay.
papers part, that is the thing. In the projects, if you ask me, I'll tell. So before joining DML, we have done various projects, like some little projects we have done. But to highlight this particular industry project, I started doing that project in my sixth semester. So that's where they started us to do calibration with the device. So the initial part was calibration. So the project what about is like in Global Foundries, they have, I think I cannot say this because that is confidential. Like calibration in the sense I can tell the general overview of what is calibration. You have one experimental device that is behaving, that behavior you can see as an real-time experimental data. Like you can, the device will have some specific dimensions, gate length and channel width, all those things that will have some specific dimension. They will have the specific dimensions, not a standard. And for that particular dimension, for that particular thickness, and for that particular structure, it will exhibit a particular threshold voltage and on current, on resistance, all those stuff. You have to calibrate exactly the same device in your simulation.
Okay.
Because in simulation, what we do, we usually optimize the device behavior, or we try to understand the physics in the simulation, right? So for do that, you have to get a reference device, and that reference device should be your real-time device. We cannot just put some random measurements, random gate length, random channel length in TCAD, and we do the analysis, and we can match that for an experimental. So the calibration we have to do. So that is the calibration here I'm talking about. After calibration, there were next phase of the project that asked us to do some physical analysis. They given some problem statement to us, like in a particular part of the subthreshold part of the device, they had some anomaly. We have to decode that anomaly. We literally took 6 months for that particular problem statement, and we worked like anything. We were working for that even when I went to IIT Palakkad for internship. So that
Okay.
was really exciting phase. We literally broken down that problem statement, and we made some clear observations out of that, and we presented to them as well. First, we have some theory, and that theory we cannot match with our existing evidences. And the theory got refurnished, or the theory got reinvented, kind of thing, I would say. The next theory, we had some other more evidences that can explain the theory, and I proposed the theory to them, and they accepted that as well. So that is how I cannot go deep into the technicals, because NDA has been signed with Global Foundries and Sastra as well, as I was part of that project. So this is the overall
Okay.
project that we did actually. So this
Okay.
project, I've done this for my final year college project as well, but not with the same information from the Global Foundries, but with a different data available from literature.
Okay. Superna. Next, Chintu, would you like to ask any question?
How much did these projects play a role in hiring towards the
100%. So that was the point where we can able to get into Global Foundries. Like if you see, most people will say, or there is a contradiction, like whatever projects you work and whatever internships that you are going will not help you to land in a job, or whatever work you do in your project, that will not be the same that what you will do in your work. But that is not case. Some people will say like that is a case for a lot of people, because a lot of people do unrelated stuffs that might end up in a different job. Like people will work in communication domain in our university itself, you see, but they may be landed up in a company like Delta Electronics, and they do some resistor, capacitor, that kind of some other stuffs. But in our case, as you asked, I'm telling this. What we did is we literally had like to be specific, I particularly had a dream to join that company because while I'm doing the project, I'm not sure that Global Foundries will hire me
Okay.
because they only hire students from tier 1 colleges. So like to hire to be you have, if you want to hire by them, you should do some extraordinary projects, or some, you should be, at least you should be extraordinary from your whole university, not just from your department, from your whole university. It should be, you should be able to stand out. So what I thought is like, so we actually, while I'm working in IIT Palakkad for internship, for my internship, my professor, Dr. Muthubalan sir, he was like about to visit Global Foundries once, that is in Bangalore office. Global Foundries have
Yeah.
offices globally, right? In India we have only in Bangalore, and I think recently they have in Kolkata as well for gallium nitride devices. In Bangalore, we have global fabs services. So, like Muthubalan sir was able to visit Global Foundries for once to present our projects and to basically to give some presentations. What I thought is, if I can able to join with him, and I can able to get some contacts in the Global Foundries during that phase, because we did the project, right? Basically, we did
Yeah.
the project, and if we can able to get recognized by them directly, that may help, right, for getting
Yeah.
into GF. So I thought that
Yeah.
way, and I like asked my professor. He was like, he asked for us. He spent his time to because we cannot easily go like visit, for going GF as a visitor itself. It's like very difficult to us, because whatever the things they are doing in the Global Foundries is like very closed. It is very confidential. They will not give it, because that's a billion dollar industry, right?
Yeah.
Every day you see like hundreds of crores of investments is going on in fabs and saying. So like that
Yeah.
much closed environment it is. They cannot let us in just as a visitor as well. You should have some like specific objective or anything specific to get in. But somehow me and my friend got an opportunity to get in, and like be involved in that presentation as well. Uh, I thank
Okay.
that for the professor Muthubalan sir, and while we were presenting, we were able to recognize it by a person there, a talent acquisition head, Jijo. I thank him as well. He then at that time, like he told us like, you guys will get an opportunity to sit for an interview. So I was like very excited at that moment, but we waited for more days actually. Uh, After that, I had attended interview and we got selected, and I'm here.
Yeah, actually, even he told us in the class that there was no job opening at that time, and
Yeah, yeah,
only if there is a
Yeah.
job opening will you be able to sit for the
yeah.
interview and stuff like that. Now, Anna, so you mentioned that you you undertook an internship in IIT Palakkad during your third year summer holidays. So, uh, could you just tell us what you did there?
Yeah. So in IIT Palakkad, me, myself, and my friend Yogesh got the opportunity to do internship there, and I was working in NPolar based gallium nitride. He was working on Alscan based devices. Okay. So like it was like a very basic project. I won't say it is a project. It was a learning, rather you could say. When you go for an institutional internship, you will get to know some learnings. Unlike industry internship, if you get into some institution, there may be some other institutions that may offer some projects as well. But what we undergone was like a learning phase kind of thing. So yeah, so like that. But that particular learning helped me to uh, get filed two patent actually. So the
Okay.
idea came from that particular internship actually.
How
Okay.
did you gain that internships in IIT Palakkad?
My professor actually sent our resumes to the particular faculty in IIT Palakkad. He is Arvind Ajay. He was actually very like he was also a very inspirational professor, because I thank him for recognizing our skills and talent to go for
Okay.
the internship. I think
Anna, okay.
every year Muthubalan sir sends uh, IIT Palakkad internship from our lab, I guess. If you know, I think, right?
Yeah.
I think
Now
your
for
seniors, your
fourth year,
first year seniors, I think have now went, right. Shivabal and Girish,
in the last
my
summer.
juniors. Yeah.
Okay. Anna, in during your research, you used the TCAD Centaurus TCAD tool provided by Synopsys, right?
Yeah.
So, how was your experience with the tool, and uh, was it quite difficult to jump into the projects directly and then learning the physics behind the models and all the parameters and stuff? And how well did the tool support you? Like, you can just tell me how you learned to use it effectively, because initially, uh, what everybody will see is just a workbench with a lot of rectangles and maybe some tools. And how well did you equip yourself with all the knowledge as of how to simulate, process, and build the device?
Okay. So first thing I would say, like for learning TCAD, if you want it to learn easily, I would say you must have some strong device physics foundation. If you have that strong device physics foundation, whatever we see in the TCAD, Centaurus TCAD workplace, right? That is like you can see it is solving some Poisson equation, electron hole, Poisson electron hole equation, all those things that is related to device physics only. So learning this TCAD is like you have to do it parallelly. You have to learn the physics aside, and you have to understand. I won't say to learn the software. The software is learning. The software means you have to see where is the home tab, like how to access the S device, or how to access, how to edit that SD to, like that is just like makeover things that you can do in the TCAD. But the real thing you have to be very strong or maybe very particular about is device physics, like, so that will help you to make yourself equipped with the tool in such a way that in any case, if you been given with any problem statement, you can able to solve it quickly. So the device physics will help you 90 percentage in the TCAD,
Okay.
because you can see in the TCAD manual there are a lot of models. The physics behind like basically what is the model is based on physics, right? If
Yes.
you are able to strong in physics, the models whatever listed there is just mathematical letters. You can see mu means mobility. Mobility you should know, like it is an intrinsic property of a material rather than extrinsic property of a material. So mobility is an intrinsic property of a material that you should know. You cannot tweak it, like for silicon it is will be around 1450 or something, right? You cannot like if you want current, you cannot put that mobility mu equal to 2000 or some 3000, like that we cannot put randomly. To know up to what we have, we can like tune, you should able to understand the real physics or the intrinsic physics behind it. Like I said, the learning happens continuously. The first thing I would say to have a clear idea in your mind is just be consistent. Whatever projects you work for the sake of, not only for the sake of device physics or device modeling, I would say whatever projects or whatever domain you will work in future, please just be consistent towards that, and you can able to see the results bit by bit. We cannot see the result in a single night, right? So it is a process. It is a continuous learning process. Don't just focus on the result. You just concentrate on the process. That will help you actually.
Okay. Anna, one general question. Do you
Now,
Okay,
Sorry.
Anna, do you think that internships are mandatory during the 4 years in college to get a job, or should everyone undertake at least one internship?
It is not like it is mandatory for everyone to get an internship to land in a job. It is not mandatory, but if you have the chance, you just please try that internship, because whatever learning you will have in your in your curriculum in the colleges will help you at least anywhere in any particular work you do in future. I had that experience, right? Like I said, if I have not gone IIT Palakkad for internship, I would have missed two patents. So two patents, imagine that. So that is the learning that you will have. Like anything, if you have any opportunity, just go and explore. So that will
Okay.
help you definitely. But it is not mandatory for any job to land in.
Now, what was your experience in the interview process?
Interview process. Okay. Uh, shall I answer this? Okay. Mm,
Like, what was the interview
Uh,
process or the role
it
that
is
you're working on?
conflict
to highlight
in the
in
company.
in
Yeah,
core industries interview, I have 100% success rate actually. I have three interviews attended in
Okay.
core industries, in our core industries. First, I attended an interview in Keynes Semicon. You know about that company?
Yeah, yeah.
I
KY.
rejected
Yes.
the offer. Actually, I rejected that offer. Next two times I've been interviewed by Global Foundries.
yeah, yeah.
To focus on this Global Foundries interview part, like in movie you can see, right? You can able to see like five people sitting and you will be shoot up with questions, right? the you can see the real heat in interview that you have been not experienced that in your past 4 years of the journey in your college life. The experience that you will get in an interview, the core company's interview, to be specific, the companies like Global Foundries, they ask questions like very deep questions. They will ask you must be prepared for an expert level to answer those questions. Like it will be like that. But if you have been worked on any projects, that will help you to answer these questions quickly. See, for me it was easy for me to attend because I was able to present in my BTech third year itself that projects what we worked on in Microsoft Teams Meet, right? So that made me to think clearly like what they can expect from me. So because of that, I was able to prepare accordingly, and I can able to put that in the interview. And finally, I asked for like interview. I asked, you cannot ask directly the feedback from your interview. They won't say. You should ask like, can you please suggest me what I can learn in. So this is actually you can take like for all I'm saying. Whenever you attend any interview, at last they will ask question like, so do you have any questions to us, like that they will ask. You should not say no. Okay,
Any questions? Yeah.
you should say like, yes, I have a question for the next process, what I can learn to improve my skills, any suggestions from your side. You should ask like that. This question indirectly what will happen to the interviewer mind is they will give you the feedback first, and they will give you the signs of whether you get selected or not there itself. Like that you
Okay.
can it will not be
Yeah.
the most piece, but you can ask these questions to just to see your performance in the interview from their perspective. Are you able to get me? Like
Yes,
I
yes.
asked this kind of question. One interviewer what
Yeah.
it is like, I will be open to you. uh, Literally you are like talent that we need to have in industry. You are such talent we need to have in industry. He said like that openly. He said like that in interview itself.
Okay.
uh, like that, that's it. And they said some things to study for the job role that mirror. It is basically statistical process control, those stuffs kind of thing that we like. Statistics we need to focus a bit because it requires in our job. So that suggestion he told. So this might be useful for anyone that they may go for any interview. So this was my experience actually. Like you will, first they will ask about, for any interview they will ask about self introduction. Second, like you have to be well prepared about your projects, because what they will do is, if your project is based on microcontroller, they will bring an microcontroller expert to ask questions to you. If you are doing projects in gallium nitride, they will bring an gallium nitride expert to ask you the questions from like that expert will ask you the project related questions too. So unlike other interviews, I found this interview was very organized, and like their analysis was very specific. It was like very different kind of experience that I had. I really enjoyed the interview actually.
Okay, okay. Um, so I would like to ask you that what according to you are the in-demand skills that any student of any department who has interest in VLSI should possess in order to be industry ready?
In demand skill you are asking.
Yes.
There is, I think, one in demand skill that is always in demand. That is the skill is confidence. You should have confidence, first of all. So that is the first in demand skill. The next skill that I would say, because this the term you are using, right, the in demand skill. So that is not that skill. That particular skill is not always constant, because few years back, if you see, people who have coding knowledge is an in-demand skill. I'm saying from 2000 to 2010. That was a golden time for IT, right?
Yes.
So that period, if you see, so this particular term, in-demand skill, so that particular skill always keeps changing. So we
Yeah.
cannot tell that. For now, in today's world, we see everybody started investing in semiconductor. So the in-demand skill in the industry is knowing semiconductors, semiconductor, to be particular, semiconductor device physics and IC fabrication. I would say these two are the in-demand skill for current. I mean, for the current today's world, it is the two in-demand skill. I would say just study deeply. And I would say for studying the semiconductor device physics, you can take Robert Pirate book. So that is the Bible of semiconductor device physics for beginner. That will be very easy for you to understand quickly and easily as well. So that is like, if you study that book, you can master any device. For IC fabrication, you have Campbell and Plummer, I guess. Those are the two books you can refer.
Okay.
And you have to interlink these two skills, device physics and semiconductor fabrication. You have to interlink these two skills to be in semiconductor industry.
Okay.
No, is it enough that studying this VLSI track? We have VLSI track in our college. So this device physics, IC fabrication, and then uh, like this
CAD for
semiconductor
VLSI
domain
and
subjects we
packaging
have.
of
Yeah.
semiconductors.
Is it enough studying this to secure a job in core companies?
Mm,
Anna, so yeah,
actually, no.
Anna, if
Yeah,
you, I think you might know, they had introduced a VLSI track for students.
yeah, yeah.
Okay, so
Yeah.
he's
Vasco
asking
sir
if,
was into.
yeah, yes, that one. So if we study only that, is it possible to
Is
get
it
placed?
enough to secure? Yeah. Yeah.
Yeah.
So see, in any university you take, this is not for Shastra alone, I'm saying, for any university you take, the curriculum what they designed is not for placements actually. That is just to get an idea what will be that particular domain or that particular track. To be master of that field, we have to spend some extra time to do that. Like, for example, this VLSI track you say, right? So what are the subjects they have? Can I uh, get that? What are all the papers you have?
Starting with the
Yeah.
device physics and
Device physics.
either device physics or device modeling, and
I
then we have
won't. I won't say to, yeah. First here itself, I won't. Like I won't suggest to take device modeling here. I would suggest to take device physics first, because device modeling will happen only if you know device physics. I don't know how they are parallelly introduced this device physics and device modeling as an elective. So they have to keep this device modeling as an elective for the next course. Actually, only
okay,
if you study device physics, then you can able to understand what is device modeling. So
okay.
okay, this thing, okay. For, so I won't consider device modeling. It's just the device physics you have next.
So in this
And
semester, that is the
IC
fifth,
fabrication.
IC fabrication. Okay, that is nice.
and then along with that we have CMOS VLSI design. CMOS technology.
CMOS, VLSI design part. Okay, okay.
Okay.
Those
And
two are in fifth semester. Uh,
in the sixth
Next,
semester, we have CAD for VLSI and what is the other paper?
I think
packaging, you were mentioning something, right?
That is in the seventh semester.
Ah, you
Packaging of
see, here,
semiconductors.
like, we have to understand something here. So, in semiconductor industry, whenever we say the semiconductor industry, there is like no specific vertical we have. There are actually four verticals we have in semiconductor.
Okay.
So you guys able to know that?
No, no, actually.
not I.
First part is design part. What we do is first is a design part. Okay,
Okay.
we'll design the chips actually. So that is the design part. That is the, I would say, the core back end of the semiconductor. I mean, sorry, core front end of the semiconductor. I would say the design part. After this design part, you have to fabricate it.
Okay.
So the fabrication happens in a foundry level, right? So
Okay.
after this foundry level, testing will happen, packaging and testing will happen. So this packaging and this designing, this is not like my domain. I am in this middle vertical, the fabrication part.
Okay.
So like they will fabricate in nanometer scales, right? Nanometer, micrometer scale.
Yeah, yeah.
So that means the foundries. You will be able to hear nowadays the term foundries so many
Yes.
times. So this foundries. So these are the specific verticals you have. Like we have in our university, we have this TIFAC core building where they
Yeah.
most people, I think mostly people from ECE, if they want to do any mini project, they will go to that particular building and they will do some, like you said, CMOS designing, this RTL, Verilog, all those things. Those are all design part.
Okay.
This packaging, you see, this packaging. I would say, in my point of view, I would say, I will not recommend you to get into this particular packaging domain because this has nothing to like you cannot invent you can in this domain, but I wouldn't see this as a very much fascinating domain because packaging is like you already have a fabricated die with you. You just need to package it to protect from environment. That's it. That's it. Package is all about. The die, whatever we have from the foundry, you see, if it is exposed to this normal environment, any small dust that may cause the chip to fail. So you have to package it properly. That is IC packaging, you would say. So this design part and packaging, this is the other 2 point. In between, what we have is like here only we will build the like most smallest
Yes. Chip.
things in the world. Most smallest things we build here in the foundry domain. So I would suggest you guys to focus this domain specifically
Okay.
because this is the booming domain in today's in India as well, and all over the world as well. You see, recently TSMC have released their quarterly results, Q3 results. They have mentioned around $980 billion in revenue alone. Right? In revenue alone, they generated $980 billion. Their share
Okay.
price was shot up like anything after that they announced. So this is the demand what semiconductor foundries are getting focused nowadays because of this geopolitics.
Okay.
So for this particular domain, you need just two things: semiconductor device physics and IC fabrication. If you can able to master these two skills, you can get into this foundry job, foundry or at least foundry related jobs.
Okay.
So that is the overall point of view of this semiconductor industry. Because most people nowadays are like many people coming in LinkedIn as well in my WhatsApp flooding with messages like they are confused with this three verticals actually. So I just want to clear here
Okay.
that large amount of audience can get benefited.
Anna, one thing I want to ask: did you attend the GATE exam?
Yeah, I gave GATE I've not gave gate interestedly. I just gave because my friend told to. That's it. See, gate. I would say if you want to do master,
What's your
you
opinion
can.
on that exam?
I think you can give gate just to try. Just to try, like understand what are the questions they will ask in gate. You can just give gate. That is fine. Like to be specific. See,
And
you should have specific goals in your mind. At least in your second year itself, because if you are going to study higher studies, you have the 2 year time frame, right? The next 2 year you can completely focus on that higher studies part. If you are willing to go in some IT jobs, you have that again 2 years to completely focus on that. If you are going to, like if your goal is to get into some core industry job, again you have the 2 year time frame. So you should fix your goal in your second year itself, or rather I would say at least in third year starting.
Okay.
So your goal should be very clear on that.
Anna, so one specific question that I would like to ask is, so when you worked on TCAD, it is not that you would have got proper results or expected results every time. So what I feel is, when I don't get the results, I find it very difficult to uh, find the error that has been made in the device, and that makes me lose a lot of motivation. So in your case, what kept you moving? I mean, what kept you like stay focused, and whom did you seek help from? And also, can you just tell me the challenges that were faced during the uh, I mean, during your research, maybe
during
during that patents, filing the patents, working on
Ah,
that part.
I would like, this is not technical part, but this is the major challenge. I would
Yes.
say that I focused in my when I focused in my, like when I faced it while I'm filing the patent. Okay, so the challenge was like I cannot accept that particular challenge. Like it was that kind of challenge, you can say. So it was not TCAT. It was not my understanding on device physics. It was completely an external factor that was stopping to you to file your patent. So like what happened was, I don't want to mention the any but faculty's name here. Okay, I just want to tell that incident just to not to happen in future. Okay, so we have a TIFA core building, right, in our university.
yeah,
Yes. Yes. Now.
So usually this TCAT will be running in a server. Up to that, there was no
yeah,
problem. There were no problem up to that. We can able to log in from our lab itself, and we will work in hostel. We will work.
Yeah.
We will enjoy and do that. Okay, that is not our challenge. What happened was, one sudden day, one fine day, the license that TCAT runs in the server, right? That license got over actually.
yeah.
So Sastra have to renew that license, right?
Yes.
Yeah.
But Sastra did not renew that. What happened is, because government is providing some free TCAT licenses to Sastra, but they have some limits. They cannot run that license in server that we
Okay.
were doing in earlier case in our laptop, right? So they have to give some outputs that they get from this license to government to showcase we are progressing.
Okay.
So in VV, we don't have, so like it means what? They cannot, the licenses, they cannot run this TCAD in server. They have to run in specific PC systems, right? So like in our VV, when I was studying, in our VV, there were no systems that can match that configuration of running TCAD. So that system configuration should be very high to run that software.
Okay.
So they automatically choose an TIFA core
SOC.
in one VLSI lab. You know the VLSI lab in TIFA core,
Yeah.
Yeah,
Yes. Now.
right? First floor, I guess.
First floor.
Okay.
First floor.
First floor, after step, you could see the lab steps, that area.
Staircase. Yeah.
So there they have some good machines with some good amount of configuration. But the problem was already there are some students working on projects, some other VLSI projects like in FPGA, very long RTL kind of those things. Like they come to that lab usually and work on those systems. So those systems are reserved actually, right?
Yes.
Yeah.
So if they install this CentOS in that lab, students who want to work in that software, what happens to them?
A laptop will hang or it'll be
I mean, the
slow.
system will get occupied by
System will
some
slow.
other people.
Yeah.
That will
Okay.
create some chaos, right? Eventually.
Yeah.
Yes.
Even then, they allocated some specific systems. So, like me and my friend, we went to that lab. Like our professor, my professor Muthubalan sir, was telling that we have to use that lab. Actually, they installed in two labs: this VLSI lab and in Roche lab. They call other lab is there in SOC. Initially, that lab they have not added some specifications that are required to do our job in TCAD. Like in TCAD, you have multiple tools: SDE, SDevice, those tools, right? S Visual we have.
Yes.
In that Roche lab, the SOC lab, I'm saying in that lab, they don't have this S Visual working properly. So automatically the choice is to go in this VLSI lab, right? So what happened is we've been asked to submit a letter to access the lab, and the professor that told this to us is used some uh, unacceptable language to make this statement. Like if you come to this lab without letter, I will throw out you like a dog. Like that, he used the language.
Okay.
So, as a student point of view, imagine you are already working in an industry. I mean, like industry project with Global Foundries. You are already working in that project. You are familiar with TCAD. As a
Yes.
faculty, like he also knows us. Before that, he knows us as well. Okay, that particular faculty. So that language got irritated to us very seriously, because we are not like other students. We just came to the lab and we are exploring. We are already working on the project. It is not our fault that Shastra has installed this particular license in that lab. Before earlier, it was in server. We can easily access, right? So the
Yes.
language he used on that day, it was very irritated to us. We complained. I mean, and like on fine day, what happened? We directly gone to the in charge of that particular lab, AD. One AD is there, so we directly gone. I just asked him like, my professor Muthubalan sir was saying like, you can go to them, I can talk to him, you can access the lab. He was telling, because I was not interested to talk that professor after he used that language. We directly gone to that AD and we were saying this particular thing, and he suddenly came in and he stopped me. He was telling something to him, and after coming outside of his cabin, the AD cabin, he was asking to me like, uh, you don't know how to talk to a professor. Your attitude is very wrong towards the professor. He was telling like me. He was telling to me like that. That particular professor was telling to me, your attitude towards professor is very wrong. I don't know what I talked to the AD that much attitudinally. Okay, I just asked him, like, my professor was telling that we need this particular system for doing our patents. Like that, I told. I don't know why he had that particular thing in, like, vengeance in our. I don't know. So after that, what we did is like, we found out people coming from our lab to that particular. So earlier, when TCAD was in server, there were more number of students were working in TCAD, right, from the laptop itself. So they
Yes.
were going to that lab. We observed that most people, I mean, those people are also facing the same issue with the particular faculty. What we
Okay.
did, we complained this to Bosco sir, and he knows me from the third semester itself. Whether I talk to this, how I will talk to a professor, whether my attitude towards the professor is right or wrong, he knows me very well. He then directly informed him, and like issue was over. Then we got allocated a system permanently to us. Like that system, nobody can touch. That is only given to us alone. That system is given to us alone. Like that happened actually, that event.
Oh.
So that is the
Okay.
major challenge I would say to highlight. So I faced during filing the patent. What happened to me was earlier my idea was okay because we had the idea already, like that but first patent idea we already had that. We already know what are the things that we need to optimize a little bit to convert that to a patent document. So to do that itself, we faced this much challenge, right? This much heat we faced from the professors and this particular lab. So after getting the system, I decided one thing. We should not stop from one patent. We should not stop here. At least I should, by the time when I leave the university, I should file at minimum 3 patent with good amount of quality innovation we should have. And I don't know what happened there. Then I think now in VV we are setting a lab with some good specification right now, I think. So like same way,
Yeah,
we decided
our labs are modified with good
all the 3
specifications.
patents were filed and published now currently, and we are waiting for grant. So that
That
was the
was
major hurdle that I faced.
really inspiring now. So it might help a lot of people facing such challenges. And then, um, so
Hannah, what are your suggestions for upcoming second years or third years?
For
to
ECE
develop
students, you are asking?
Yeah, only
anybody who has
specifically
interest
easy.
in, yeah, anybody who has interest in semiconductor technology.
Semiconductor.
Yeah.
Okay. I would say start learning device physics and IC fabrication parallelly and learn TCAD. To be
Okay.
specific, in TCAD, just don't just go with SD tool alone. Explore S process as well. There is other tool S process where you can virtually fabricate that device in the environment, in the TCAD environment.
Yeah, Anna, actually, I wanted to ask this question. How were you able
Yeah.
to manage the EC core syllabus and this research that you had done? How were you able to manage both of these things?
I won't say you just like academics and all, you should not take it as a big thing, right?
No, no,
You just handle the academics in
because
left hand.
because your CG
Mentally,
is
it's
also very high. Because how was it possible to your CGPA is also very high. So
oh okay.
so yeah, how were you able to manage like excel in both the fields?
Interest again, I would say interest. So what I will do, so to talk about the CGPA point of view, Bosco sir will always say like, அரசனை நம்பி புருஷனை விட்டுறக்கூடாது, like that he will say. So what he means is like
Uh,
when you should not leave academics part while you are focusing in research part. You should manage both, he will always say. So
Okay.
that is the mantra he will always give. So what you can do to boost your CGPA is before starting a particular semester, you will be having what are all the subjects or papers that you are going to study, right, with you.
yes.
Yeah.
In that particular papers, you are also having units. What are the units that we cover? What you can
Okay.
do is, according to me, scoring is different, reading is different.
Yes. Now.
Like if you want to get marks, your strategy should be completely different. If you want to understand the subject, your strategy should be completely different. Obviously, these two will get coincided at some specific point, but it will get deviated when your exams come. So that is the key thing you have to understand to
Okay.
excel in both of your field. So what you can do is before starting your semester, you just like for example, if you are device physics, if you are the next semester is device physics, if you assume, and if you see all other papers are easy or you can make up, if you think if you just need to understand the device physics, or if you are just need to score high grades in device physics, what you can do is before starting classes, what you can do, you just see the books, like I would say in the what the syllabus they will give, right? In the syllabus at last,
Yeah.
textbook section will be there. They
Yes.
will be mentioning what are the textbook that we can refer. I think mostly the first textbook what they will refer is the one they will ask questions from.
Okay.
Example questions, problem questions they will ask from, right? So you can take up the book and you can just see the concepts. So first unit, second unit, third unit, fourth unit should be there, right? You just see what are the basic concepts that is being listed in the book, and when you read that and you attend the class, you can able to relate that concept. Not only you can score the marks, you can also able to relate it well with you. If you study it before even your professor teaches, it will be very easy to understand things.
Okay.
So if you follow that, then you no need to worry about your CGPA, I would say.
Okay.
And you should have interest as well.
Yeah.
So, I'm telling this because just you asked, because what we were doing is in the fifth semester, it was in the sixth semester, it was very hectic to us because we have to give presentations to Global Foundries. For that, we have to prepare PPTs as well. Literally, I did I made PPT before tomorrow is CAA, means today night I was preparing the PPT for Global Foundries actually.
Okay.
So that was the heat pressure that you will undergo. But I enjoy that pressure actually. I enjoy that pressure. I'll enjoy the process. If you start enjoying things, it will become much easier.
Okay.
Because you have to understand a point here. If you are also doing like a normal student, that what if you are also being if you are also want to be in the safe play, you cannot go into industry or you cannot make a big difference, because every people are doing the same thing. If you are also doing the same thing, then how can you become something like extraordinary or like that kind of thing? You have to break that safe play, and you have to undergo some pressures, so that will only transform you, I believe.
Okay. Even I do agree with that. And so, any question you would like to ask, Chaitanya?
Anna, in general question, what are your hobbies during college days?
During colleges, I can say one incident in fifth semester, but it
Okay.
will not be relevant to our discussion. But hobbies wise, you can, if you ask me, reading literatures, research papers, because that was the only hobby that I can develop to give next presentation to Global Foundries, right? So, like that, it was reading IEEE papers, all those things. So, whenever I get lunchtime or break in my classes, I use it to read those papers, IEEE papers, literatures.
Okay.
That will people will say that is literature survey. You hear? Did you hear this term? Literature survey. Like any
Uh,
PhD scholars, if you see, what they will do is in the initial phase of their days, PhD scholars, they are joining Shastra, right? Or anywhere you see.
Yeah.
Initial days, they will do literature survey. Like they will understand in their field what are all the existing technologies are doing currently now, and how they are optimizing it, and what are all the trade-off that they are. See, basically, any domain you take in research field, I would say, it will have one trade-off. It will have many problems. So problems and trade-off is the two things that any research field will have. If you can able to break any one of them, then you can publish that as a paper in the existing paper. So that was a very key finding, I
okay.
would say. So reading literatures is very important.
So, okay. Would you like to share anything that we have missed asking you?
I'm willing to share. Don't just fall in love in your college
Okay.
days. That will be complete waste of time. Because I would say my fifth semester is my only waste of time that I had in my college days. So my fifth semester was literally it was waste of time. If I would have never fallen in love in that particular semester, maybe today it could have been some more number of patents that I'm holding. Maybe that I would
Okay.
say.
Okay. Mm. So, yeah. I would want to ask you this question. Anna, could you tell how you and Yogesh Anna, both of you, how you worked together to achieve these many things? Like
Uh,
the rapport between you and
Yogesh,
him.
I would say he was actually not in my class. I mean, we are not together in class as well. He was in ECE CPS. So different.
Okay.
He will be having different section in every semester. Uh, when we started this particular project, when Muthubalan sir asked me to build a team, I was able to identify him because all other my friends are also there. So many friends are also there. They were already involved in other projects. So I was able to identify him as a good resource, and from with Muthubalan sir, because for doing this particular project, the team members should be having minimum requirement as they should have studied this device physics elective, but he did not took that elective actually. So
Yes.
I just took him. I trained him personally, and he was also doing very good at the time. And like that, it went.
Okay. So now, what do you do as a device engineer in Global Foundries? What is the everyday life in Global Foundries? Day-to-day life.
Okay, okay. So as an intern, now I may not have like that kind of uh, like how to say like responsibilities, but even then I have, and I have to check with the uh, ethics team that whether, I mean, the team in the Global Foundries, whether I can share those details or not, but I can give the overall picture that what Global Foundries is doing.
Okay.
So will that be fine?
Yeah, that is fine.
Because
I
I
mean,
have
Yeah.
to check, because those confidentialities we have to maintain. So that's why. So
Yeah.
Global Foundries as an industry, like they are pure semiconductor manufacturing company. You have IDM companies, right? Like Intel, Samsung, and all.
yes,
They
yes.
are designing the chips as well. They are producing the. Uh, I mean, they are
Chips.
doing foundry business as well. But Global Foundries is focusing only on foundry, like TSMC, right?
Okay.
So we have fabs across the globe. We have fabs in US, Singapore, and in Germany. Okay. So in
Okay.
Bangalore, Global Foundries India in Bangalore, what we do is like we support those fabs across the globe. So fabs, you have to monitor what happens. Like if you are like, there are thousands of fabrication steps, right? You have to monitor those things because those are very very minute and very sensitive to the dimensions as well. Like if you see, if you want to deposit 10 angstrom or like 10 nanometer of gate oxide to a in MOSFET, if you're, because of your process variation, it just extends up to some 12 nanometer. That will cause your threshold voltage to shift. So like those things, those excursions, and we have some limits. So like we have some control limits and we have some specification limits. We have to monitor whether a process going above that limit or below that limit, because those limits are a contract between the customers and Global Foundries. So Global Foundries, like we have to make sure the parameters should not cross those limits. We have to monitor and control them. We have to like hold the lots and dispose the lots, like that we have to do. It is like an very interesting, like you should know basic statistics for this, mean, median, all those things stuff, very basics kind of thing. And there is other team called NPA, new product introduction. What they will do is they will engineer the device. They will do some little engineering to the devices. Like they will tweak some parameter and see what happens in the ET data. Like as I said, they intentionally do some process variations. Like what happens if I deposit this much of thickness of material, this much of thickness of this much material. What happens to the threshold voltage, or what happens to the RON? What happens to the ID drain current? Like that they see. So it will be like that. So you should know device physics and IC fabrication essentially for this, right?
Yes.
So that's what. So if you know
Okay.
this, you can. Sorry.
So, like I would ask, like, what is the least technology node that you have experience with in GF? If
Mm,
you're working on fabricating it.
I think I don't know whether I can tell this or not. Like if you see
Okay.
in general, there are, okay, notes you are asking. I'm working in FinFETs.
Okay. FinFETs.
Inputs, yeah.
So, does your
Inputs,
job
yeah.
okay? Does your job require you to use Centaurus TCAD again for uh, anything, or that is a different role? I mean, people from different team work on
Yeah,
it.
that is actually different role we have in Global Foundries, like people working in Centaurus as well.
Okay, okay.
To highlight to you, yeah.
Uh, what do you do in your free time, Anna? This is out of context question.
Free time, you're asking now,
Yeah.
currently.
Now.
Yeah,
Yeah.
I am currently engaged with this, my YouTube activity. I have to do video editing.
Okay.
I will design thumbnails, video editing, all those stuff. I have to manage that channel. All those things I would do, and I'll read financial related books in the free time. That will help you. I would suggest everyone to read this Rich Dad Poor Dad book actually in your free time. See, everyone should have this financial knowledge, basic financial knowledge,
Okay.
to understand the difference between the assets and liabilities. That will help in your future life, right? If
Yeah,
you are
okay. I'll
responsible
provide
for,
that book link in the description also.
if
That
you become
helps.
family man, you should know all this stuff, right?
Yeah.
Yes.
And then for being an entrepreneur as well.
Okay. Now, Anna, I would like to bring up a name over here.
Yeah,
We know this person called Suresh Venugopal, who was a PhD scholar in our university and now working in Tata Semiconductor.
yeah.
So I have seen you working with him only for one semester. Like you all. I mean, you three people were very focused in what you were doing. How was the relationship with him? Maybe before, maybe during the initial days of you coming to the lab. Uh, because I have not seen much of that, like much of you working with him. So, can you say something about him?
That
Like,
is because like you are saying we have not worked with him because like we were
no,
working on
no,
a separate projects actually.
no. Like, how? Because I have heard Yogesh saying that he played a very big major role in helping you learn device physics like guru like that. So, what would you say about him? Like, what role did he play in your path of success?
In initial days, okay, maybe okay. So initial days, yes, Suresh sir was like very helpful for us. Initial days, I thought not to disturb him too much because I could hear from him that so much people coming to the lab is because he is doing his PhD work as well, right?
Yes,
So because if we go and ask frequently to him, like what is this parameter, or what is how to optimize this, or how to, like, that will be very much hectic for him as well, and it will
yes,
cause some pressure for him as well, right? Because he have to focus on his second paper work. So
yes,
initial days, he was very much helpful for sharing me the materials. I would say, like he shared some materials to us, um, some on PDF he shared, and manual, Centaurus manual he shared, and like he told me like you can start with that, and from there whatever we did is like completely different because I thought to not to disturb him too much. And after that, you may have been seeing working with him because I was supporting his second paperwork.
yes,
Uh,
yes. Yeah, I know.
yeah, I
Okay,
was. He was consulting with us for his second paper actually.
okay. So yeah, that's it. So can we end here, Chaitanya?
Yeah, okay.
Okay. Thank you so much now for
Thanks, Anna.
joining with us in this podcast and sharing your knowledge. I hope this will reach many people and people who have doubts about choosing their path in life. So thank you once again. Now.
Thanks, Anna.
Thank you,
Thanks
thank
for
you,
spending your valuable
thank you.
time.
Yeah.
Okay.